Assalamualaikum and hi. So this is a presentation for group 3 about soil classification. So this is our group member, Suri, Ain, Nuzul Katerina and Farisha. So for the introduction, geotechnical engineering plays a pivotal role in the realm of civil engineering construction. It involves the investigation and analysis of soil behavior under internal loading force and soil-water interaction, with applications aimed at advancing human development. Geotechnical engineering significantly contributes to various civil engineering projects, particularly those pertaining to soil and rock. Numerous soil classification systems are commonly employed by construction companies worldwide. Examples include the Unified Soil Classification System, H2O system, and USDA soil taxonomy. For Table 1.1 is Unified Soil Classification and Symbol Chart. For Figure 1.1 is Unified Soil Classification System. For Figure 1.2 is Plasticity Chart used in the USCS. And for Table 1.2 is H2 Classification System Chart. For Table 1.3 is description of classification groups in H2 system, and for Figure 1.3 is relationship of plasticity index against liquid index.
Firstly is sieve analysis. The sieve analysis test procedure is a time-tested and effective method for determining the size distribution of particles. Secondly, we get the dry and wet sieve. Dry and wet sieve analysis is carried out quantitatively, determine the particle or grain size distribution for soil particle of size 75 micron and bigger. For soil particles of size 4.75 mm and bigger, dry sieve analysis is done, and for soil particles of size above 75 micron and below 4.75 mm, wet sieve analysis is also needed if the soil particles are coated by clay and soot. Thirdly, apparatus required. First, balance, 2 sieve, third, sieve shaker, and fourth, oven. And lastly, we got coarse grain soil. The cumulative percentage quantity is finer than certain size. Example, placing a given size sieve are determined by weighting. Points are then plotted of percent finer against lot size. A smooth S-shaped curve drawn together through this point is called a grading curve. The position and shape of the grading curve determine the soil class. Geometrical grading characteristic can be determined also from the grading curve.
Case study 1 is about earth building construction processes in Benin City, Nigeria, and engineering classification of earth materials used. Benin City is situated between latitudes 617 and 626 north and longitudes 535 and 541 east. It is the capital of the Nigerian state of Edo, as well as the seat of the Oredo local government area. Uka, Use, and Yuslu were chosen as sampling locations to categorize the soil, moisture content, sieve analysis, hydrometer analysis, and eatable limits were performed on the samples in the lab. These tests were carried out in line with the S112 eatable, tested the liquid and plastic limitations. We move on to the results and discussion. The three samples are reddish brown in color. Samples C and B contain the most and least natural moisture, respectively. The liquid and the plastic limits, as well as the plasticity index of the samples, range from 24 to 41%, 14 to 22%, and 10 to 19%, respectively. The fractions of soil samples A, B, and C that pass through the sieve with a 0.075 mm opening were 39.7%, 40.5%, and 44.8%. This indicates that the soil samples are coarse grained. Based on the case study 1, the conclusion is Suitable soil for earth building construction is readily available in the study areas. Next, this study verifies the findings of many studies on earth building construction techniques, which have observed that there are significant local variations in the procedures and methods of material selection in different areas. Based on the Unified Soil Classification System, USCS, soil samples collected at USLU, Oka, and USE were classed as silty clayey sand. These were classed as A6, A7, and A4 respectively by the Ashton system.
Case study 2 is the foundation design of high-rise building. High-rise building is a deep foundation such as pile, piers, or caisson are often preferred for high-rise building on soft soil as they can bypass the weak upper layers and reach the more competent lower layers or bedrock. Deep foundations can be classified into two types, which is driven and bored. The examples of area of high-rise building, number one is the La Aztia building in Mexico City, Mexico. Number two is the Burj Khalifa in Dubai. Number three is the Incheon 151 tower in Incheon, South Korea. And the last one is a high-rise tower in Jeddah, Saudi Arab. This is the result and discussion of my case study. The geotechnical investigation revealed a complex subsurface profile at the construction site. Soil samples were collected at multiple depths, and laboratory tests indicate significant variation of soil properties, including cohesive clay layers, loose sandy deposit, and dense gravel horizon. This diverse geotechnical profile poses challenge in determining an optimal foundation design. Load analysis indicate that the high-rise building needed to support substantial vertical loads due to its height and the anticipated lift and dead loss. Finite element analysis (FEA) simulations were conducted to assess the performance of the proposed foundation design under various loading scenarios. The numerical analysis play a crucial role in optimizing the foundation dimension and reinforcement details. The result of the FEA confirmed that the selected foundation system would meet safety and performance criteria, ensuring structural stability and preventing excessive settlement. In conclusion, the comprehensive research and analysis undertaken for the foundation design of the high-rise building result in a robust and optimized foundation system. The selected foundation type, supported by numerical simulations and adherence to code, ensure the structural integrity and long-term stability of the high-rise structure. This case study exemplifies the importance of true research methodology in addressing the unique challenge associated with high-rise construction and foundation engineering.
Moving on to the next case study, which we had choose the articles about soil characteristics analysis with unified soil classification system. So the introductions is about the passage underscores the importance of researching soil characteristics, particularly in regions like West Java, Indonesia, with clay subsoil. It emphasized the role of the Unified Soil Classification System, which is the USCS, in understanding soil behavior for effective construction. The study analyzed soil samples from Jababeka and Nipo Cikarang, which focusing on swelling potential. For the result in discussion part, soil samples 1 and 2 from Cikarang exhibit high moisture content, specific gravity, and also the significant Atterberg limit variations. Jababeka 1 is identified as high plasticity clay in USCS, which is CH, and H2 A76, while Lipo is high plasticity clay in both. Next is the soil mechanics test indicates that the consolidation characteristics, which prompting further analysis for swelling potential. The correlation between consolidation characteristics and also the mineral content, particularly colonite in Cikarang soil, is detailed. Expensive soils like Cikarang are assessed for swelling potential using methods detailed in table 3, with showing a very high swelling capacity in Jababeka 1 and also the Lipo Cikarang soils. The last part is about the conclusions. from these articles that we had concluded that the findings from the analysis in this study indicate that the predominant expensive clay minerals in the Cikarang area are primarily constituted of colonite, displaying a significantly elevated swelling potential and a potential volume change falling within the 10 um, to 13% range. So then, to change the conditions of expensive clay soils, measures to promote soil stability can be implemented. Moving on to the next case study 4, which is about an article about a system of soil classifiers. So the introductions for these articles is about this article presents a comprehensive field and a laboratory study of soil behavior in foundations, subgrades, and slopes, and also represent parts of a larger study conducted by the Georgia Departments of Highways. So the objective is to develop a soil evaluations table that can be applied to soil prevalent in the state. The resulting classification has proven vital in improving the department's understanding of soil behavior and has been invaluable in the designs of road sections. Moving on to the result and discussion part. The studies highlight the poor soil quality in northern and central Georgia, characterized by highly porous decomposed rocks and micaceous soils. Despite adequate compaction, these soils lack structural integrity due to a high void content, which exceeding 40%, which is making them insufficient to support road vehicles. The focus on clay components reveal significant swelling when wet, disrupting soil structure. The study emphasized the importance of considering volume change limits for soil mixture to prevent failure under operating conditions. Evaluation maps based on porosity and total volume change have been developed for design consideration. The last part, which is conclusions, we know that soil failure is primarily due to shear, and shear is directly affected by density. So choosing a soil mixture with high compaction density, which maintains its density during use, will reduce the shear of the composition. Strength increases and shear strength increases. Consequently, heighten the stability. It is recognized that currently established limits do not represent a comprehensive and final solution to soil classification. However, so far these constraints have proven to produce excellent results when applied to Georgia soils.
Okay, for the discussion, both system H2 and USCS categorize soil into coarse grain and fine grain based on the number 200 sieve. They exhibit some similarities and differences. Both systems rely on soil texture and plasticity for classification. The H2 system designated soil as fine-grained if over 35% passes through the number 200 sieve, whereas the USCS system sets this threshold at more than 50%. Notably, a coarse-grained soil with 35 fine grains behaves similarly to fine-grained material, making the H2 systems more suitable for construction application. In summary, both systems play distinct role in civil engineering construction. Their consistent use in various aspects attest to their utility, providing significant convenience as construction practice evolve and become more intricate over time.
So the last list is conclusion. Okay, as we know, we get that classification is fundamentally crucial in any scientific field, as it provides a systematic framework for addressing research. Beyond its theoretical importance, a classification has practical application, especially in endeavors such as soil survey programs, and the mapping of soil is a given based on the region. The primary purpose of soil classification is to aid geotechnical engineers in anticipating the properties and behavior of soils. This is achieved by categorizing them into groups with similar response based on index properties. Globally, soil classification offers valuable insight into the physical nature of soils. However, in-depth analysis and data trends indicate notable limitation in the established boundaries for various soil groups within traditional classification system. A significant issue arises with funds which begin to exert a substantial influence at fraction smaller than threshold set by existing classification system. That's all from our group. Thank you.